just 3 lines. There is a main function. So fn in Rust specifies function, and then there is a print statement. But notice that there is an exclamation point at the end of that print. So this print ln stands for line. So print line, and then of course hello world. And you always so the Rust programs typically need you can't omit the semicolon. If you omit the semicolon, that has some significance. So I'll come to that. What happens when you omit the semicolon? When a statement is the last statement in a function, then you can omit the semicolon, but otherwise you need the semicolon. And to compile this, hopefully all of you have installed the Rust routine on your laptop. So you just say rust c hello.rs. So that repository which I written here, there is a directory called hello. So you can go and compile. I'll show you the demo so that you know how to do that. Let's go to a this this hello.rs has this file which I showed on the slide. So you just go to C, which is similar to the GCC, and hello.rs, and in the directory there is a hello binary which is created in this standard binary, and it will print nothing different from what you're used to. But in Rust, there is a built-in package manager, a build system and a package manager for environment. I think the Ruby form which I shared with you asks you to run cargo version. So hopefully you have it installed on your laptop. So creating a new project using cargo, you just type the command cargo new hello world, and it will create a directory. Let's see what happens. So I have an empty directory called demo, where suppose I type cargo new hello world. Then it says I see a message created binary application hello world package. Now if I see the directory, there is a hello world directory. So let's see what's there in that. So the hello world directory has a file called cargo.tom. This file format is named after the person whose name is Tom actually. So it's Tom language, Tom, and then there is a source directory and there is a main.rs in that. And this is like this. This is the project contents. And what does the Tom file have? So it has two sections. The first section is square bracket parts. So there's a package, but there's a new package created called hello, but the same name as the directory, the project name we gave when we typed that command. And then some version number, some edition. This edition refers to the Rust edition, and then some dependencies. Right now our program doesn't have any dependencies, so the dependencies is empty. And what does the main.rs file have? So it just has that hello world. So by default, the cargo command just creates the simple hello world program and it populates that. So the cargo is useful for many things. You can also compile and execute using cargo. So if you just run cargo build in the project directory, it will compile the binary, and the output looks something like this. When I say cargo build, I get some compiling hello world, but there is some change there, and there is some strange word here. It says unoptimized and debug info targets in 0.15 seconds. So what does that unoptimized stand for? So by default, so before I say that, so cargo build, if you're tired of writing to, you can just shorten it to cargo build. And by default, debug symbols are embedded into the compilation output. So the binary which is created when you just type cargo build, it will have debug symbols. What that means is that if you want to run this program under debugger, compilers have to insert some symbols so that they can map program binaries with the source code. So those are called debug symbols. So typically, the debug symbols will slow down the program. So by default, Cargo or Rust assumes that you are debugging your program, so it will insert debug symbols. If you want faster binary without the debug symbols, you should run Cargo with -- release. That will give you a faster executable, but you can't debug that executable because it doesn't have debug symbols. You can debug using printf statements, but you can't run the program under a debugger. And the output of cargo build release will be it's the same as this cargo build, except that now it says optimized. See, it's unoptimized and debug info. That is not that is missing, and it just says optimized. It's an optimized cargo. And this also can be shortened to cargo B minus R. So if you're tired of writing cargo build minus release every time, you can just say cargo B and minus. And executing the program, so this is the building, and executing, you can just run cargo run minus R or even cargo R minus R will work. So let's just do that. Just for complete this. So here I have the demo program, it says hello world, if you go there. So I say cargo B, then it's the unoptimized version. I say cargo B minus R, it is the optimized version. Then I can say cargo run the optimized version. Then it says hello world. So it says that finish release optimized. So if you run cargo, then every time you can check whether the binary has been or the source file has been compiled. If it is not compiled, then it will compile and then it will run it. So where are these files located? So this is the contents of the project directory. So the hello world directory, it will have this cargo log and cargo comments, and then this is the source main directory. There is this target directory will have this debug and release. So the debug directory has the compilation of the program with the debug info, and the release has the compilation of the program without the debug info. We can see this here. It's showing your eyes. The slide I highlighted a lot of other files. So here you can see that it's target and it's a debug. And there is a hello world binary here. So if you want to run the binary without compiling, that is without using cargo, you can also run that. So here what I've done is I've directly run the hello world binary and it's printing code instead of running it through cargo. So you can now shift the binary. There is binary to a place where it can be run. So any question? Cargo is a built-in package manager and build system for Rust. Now you can have multiple programs in a single project. So this the one I showed you had only a single name, but you can have multiple programs and you can the project structure will look like this. So you will have a single cargo.toml file, and then there is a source. Now instead of the main.rs being in the source, you put it under bin. So in bin you can put multiple files, but each of these files should have a main.rs. Yes. So this is multi-bin is the example. So source bin has alpha.rs, this is the main file, and then beta.rs also has a main file. So you can have multiple binaries, but each of those binaries needs to have a main function there for this to work. And you can run, now when you have two binaries, how do you specify which one to run? You specify the name of the binary. So if you want to run alpha.rs, just say cargo run -bin. So So the minus minus bin is required to specify which binary you want, and then alpha, otherwise can't go run minus minus bin. So let's talk about variables. Any language, first thing you do is declare some variables. So variable, so the thing about class is it is a statically typed language. What that means is that at compile time, the compiler needs to know the types of all the variables. Are the variables integers or strings and so on. So declaration of variables, you use the keyword let. Then you give the variable name. Then you have a colon and then you have a type. And here the type of this variable is uint32, and you're setting it to the number 5. So the type of the variable is specified after the colon. If the type is not specified, then Rust will try inferring. So Rust has something called type inference. So from the context of the program, Rust will try to infer the type of the variable. So here I have this program. Here I have not specified the type of x. I said let x equals 5. But then I specified the type of y. That y colon u32 is 10. So y is an unsigned 32-bit integer. Now here I am doing a calculation. Println. The syntax is given. What this curly bracket says is that so curly brackets will take the first argument after the string and it will insert that value here. So this println statement is saying that print the value x plus 1. Now since x is being added to y and y is an unsigned uint32, it's an unsigned 32-bit integer, the type of x is inferred as uint32. So when this type is not specified, Rust will try to infer it. Running this. So this is the infer.rs has the program I just showed you. So if I run this R program minus then it's giving some error. So it says that the variable is unused. I'm not sure why that is happening because we are using the variable x plus 1 here. But it's I have some other files. So I'll try to find out why it's giving that error. I've never seen that error before, but it's in that error. So the point I was trying to make is that the program will compile because the influence, type influence in Rust will infer the type of. So here the type of x is inferred as utility. And other thing I want to show you is that the type influence will appear in the Rust in the analyzer extension. So I think hopefully one of the instructions which was shared was that it asked you to install VS Code and also the Rust analyzer plugin. So here in this Rust analyzer, so I opened this in VS Code and the Rust analyzer plugin is already. So what is happening is that the source code does not have this OM, but the Rust analyzer plugin has inserted this name. Even though the source code just says x equals 5, the Rust analyzer plugin has figured out that since x is being added to y is equal to the type of x. So the advantage is the Rust analyzer plugin is some validating filters which I can code faster. Suppose I remove this. So what I'm actually there, if I remove the y, Now, why I had explicitly specified as unit material? So, since I removed the y, the rationalizer and use Rust. Rationalizer is using Rust in the backend, and Rust compiler in the backend. Now, the inference of x is IITB. So, by default, the Rust compiler applies the type integer, the signed integer type to any variables, integer variables which don't have a type associated with them. So here, when we say let x equals 5, the Rust compiler sees the 5, it's an integer. Then it says, by default, it assumes it is a signed integer. But now, if I change this 5 is called a literal, it is a constant in the program, it's a number literal. So here, number literals you can specify the type of number literals. So here I put U32. Then rationalizer has changed the type inference to U32 because I'm assigning x to a literal, and you can specify the type of a literal by adding the type at the end. So now the type inference has changed there. Any questions about this type inference? Yeah. It's just for printing. It's like it's a placeholder. So suppose I say the sum of, if I want to put the string there. So then wherever the curly braces are, the expression which is here will be, the value of that will be inserted. Any other question? So variables in Rust are immutable by default. What I mean by that is this code will not compile. So what is happening in this code? So I have x equals 4 and I'm printing it, then I'm changing the value of x. Now I have not explicitly said that this variable is mutable, so this will throw an error. It is there in the directory under the variables if you want to try it. But then how do we define mutable variables? It's not very difficult. You just put a mute keyword. Just put the mute keyword in front of the variable name, and then you are explicitly telling the compiler that I'm going to change the value of this variable. So please allow me to change the value later. And the reason for this immutability is that Rust borrows ideas from a lot of other languages. There are some languages like Haskell where all variables are mutable. There is no, all variables are immutable. There is no notion of immutable variable. So that leads to programs which are easier to reason about. If you know that the variable value will not change, then there's some invariants which apply. So it's just one of those conveniences. Rust recognizes that those ideas were good, but the mutable variables are also convenient. So let's have the best of both worlds. By default, I'll assume the variable is immutable, but whenever I want a mutable variable, I just put a mute in front of it. One notation which changed was that the curly braces, think carefully, so I had put the curly braces and I put the x outside, but now I put the x inside the curly braces. So this syntax also works, but that cannot handle expressions. So this second form, you can't put x plus y in there. You can only put variables. That is, you can't evaluate an expression inside the curly braces. You can only put things like variables which have already been evaluated, where values you can where those variables can be inserted into the curly braces, but you can't put x plus y into the curly braces. Let's talk about data types. So I said variables, but there are many data types which are there in Rust. Integer types, you have all these integer types. You have 8-bit integer, this is a signed integer. I8 is a signed integer, U8 is unsigned integer. Similarly, you have 16-bit, 32-bit, 64-bit, and 128-bit. There's also an architecture-dependent I size and U size. Usually 64-bit. Most of the laptops which you are using are 64-bit operating systems. So this U size will be a 64-bit integer. So what is the U size is typically it's the size of a pointer. So it is usually used for indexing arrays or other collections. So if you have an array which I will describe later, then the index into the array has to be a usize. So if it is some other integer, then you have to convert it to a usize before you index into an array using that integer. And as I showed, an integer literal, you can specify, literal is basically a constant, so an integer literal, then you can specify by adding this this kind of constant, then followed by the type. U8 means that this is a 8-bit unsigned integer. This is 25 followed by I32 means it's a 32-bit signed integer, and so on. Then floating point types, there are two of them in Rust, F32 and X64. So typically operations between different types will fail unless you explicitly define operations between different types. It can fail. So for example here this code will not compile. So what's happening here? There is a X which is a floating point, 32-bit floating point, and Y is a 64-bit floating point. If you try to compile this, it will say there's some errors. Let's look at that. So I have that program which I showed you in this float air.rs. So let's see. Hopefully it doesn't complain again that this unused variable. So it says that there is an error. It says that no implementation of F32 plus X60. So they are mismatch types. So Rust has not defined the addition between these two objects. So that's why it's failing. So you can, by changing the types, you can fix it. So if you actually you don't need to change the types. What you can do is that you can use this as keyword. Here, what I'm doing is that I'm saying that interpret X as a 64-bit floating point and then add it to Y. This will pass. Or interpret Y as a 32-bit floating point. So this is a lossy conversion because a 32-bit floating point, all 64-bit floating points may not perfectly fit in a 32-bit floating point. So there may be some loss here. But if you are willing to take that loss, then you can do this. So these two operations will work. So this as keyword allows you to convert between types. When such conversion has already been defined in the compiler, or sometimes you can define such conversions yourself. So let's look at the Boolean and character types. So nothing surprising. So false and true. Those are the Boolean types. And we have the Boolean logical operations. You can try this. So this is logical and this is logical or, and so on. Then the character type is it represents any 4-byte type which can represent. It is a 4-byte type which can represent any Unicode code point. Like this, for example, this emoji, this exploding head emoji, that can also be a character type. Let's see what the Rust analyzer says. So here I am not given any type annotations. There is no colon and after the variable name. Let's see if I can find this. So this is the char.rs. Let's look at Rust analyzer and see what it says. You notice that so Rust analyzer has annotated those two as character, the char type, and so if I run that, you can see that it is printing that exploding head emoji. So far, nothing surprising, all the usual conveniences you would find in any modern language. Let's look at compound types. The first one is something called a tuple type. If you have a fixed number of variables with different types and you want to group them, then you can use this tuple type, and the syntax is just parenthesis. So this x. So this x has type. It's a tuple having 3 elements or 3 compartments. The first one is an 8-bit unsigned integer, second one is a 32-bit floating point, and then the third one is a bool. And I'm assigning it to 38, to 5.5 and true. And then I'm trying to print this x, but there is a new syntax here. So this colon question mark, that allows you to print objects for which are more complex. So if you just put the parenthesis, Rust will complain that I don't know how to print this. Then you have to tell the compiler, try printing it, try harder. So think of this as try harder. Sometimes it may work, sometimes you have to implement something called a debug trait for this to work. I'll come to that debug trait later, or traits later. And how do you access the compartments or the components of the tuple type? Just put a dot and a 0, 1 and 2. So it is 0 indexing. So if you want to access the 38, just say x dot 0. If you want to access the 5.5, that is the second component, x dot 1, and the third component is x dot 1. So sometimes it's convenient. Suppose I have a xy coordinates and I want to have a type which captures those xy coordinates. This tuple type would be a simple way to capture that. So the question was that can I access it? We can just try that. I'm not sure. Can these constants be replaced with x dot I, where I is a variable? I may have to be a u size, but we can try that quickly. Make this smaller and see. So this one, so saying, can I do this? No, right. Is there it? Minor is the float level implementation. What is that? No field ion type, so it doesn't work. So you have to use an array to want that kind of. That syntax is not working. No field I. Okay, so it's being interpreted as a particular field. So the field name. So 0, 1, 2 are not integers. So this is tuples is just a convenience which may work in some situations, but later we'll use structures which are there in most other programming languages to group disparate types. When you use structures, you can have names for these different components. So here the names are non-descriptive. There is 0, 1, 2. So sometimes that may not be convenient. And arrays is, so here the tuples is these 3 components could be of different types: unsigned integer, floating point, and Boolean. But when you have a fixed number of variables of the same type, you can use an array. And if you want a variable, that is a number of variables you want it to change. Here the array is fixed of size 5, but if you want it to change, then there is something called vectors which I will describe later. And arrays can be indexed like 0, 1 is the first object and second object. So nothing surprising there, it's like a Python syntax. Yeah.
Can you leave the type blank? Will that interpret it or
The question was, can I leave the tuple blank? I think you can. I think it will do the typing things. So, if, for example, if rationalizer runs the compiler in the backend, so even without compiling, I can. So, if you notice that it has interpreted it, but there is one difference. I had explicitly defined 38 as unsigned integer of 8 bits. This is interpreting it as I32, and so it is interpreted using some default typing. Any other questions? So let's look at functions. So we look at variables, let's some data types. Let's look at functions. So what is the syntax? We already saw the function syntax for main. So you have a function name, parameters, and followed by the return type. So you have the function name, you have to specify the parameters, and there is a dash followed by a greater than symbol, an arrow, and then the return type. If, for example, this function increment, it just increments the value of an integer. It's a signed integer. So this function so we are specifying the name of the function is increment, then I have a variable name, and then colon and the type of the variable, and then I have the arrow, and the return is also a signed integer of 32 bits. Then I am saying return x plus 1 and the semicolon here. So when I say let x equals increment 5, the value of x will become 6, and then I print that value.
So what is the process is the type of tree? For instance, x was an array. The type of tree.
So if x was an array, then it will just be it will show the square brackets and the type of the inside. So this function, it can be defined before or after. As long as it is in the same file, then it will compile. It is not necessary that the function has to be defined below the usage. So that you can. It's not. This is just the example I put it in the bottom, but it could be before also. The function has to be in the correct scope. What is scope is beyond the scope of this tutorial, but you can figure it out as you become more proficient in Rust. The compiler will help you figure that part out. So now there was a return statement there, but we can also return without the return statement. So I said that the semicolon is sometimes optional. If you have a function ends with an expression and has no semicolon at the end, that value will be returned. So instead of saying return x plus 1, if I put just the value x plus 1 in the last line of a function, then the last expression in a function will become the return value. So this function is also correct. So this function is, previously I had return x plus 1 and a semicolon. Now I am just putting x plus 1 there. So the last expression in a function, if it doesn't have a semicolon at the end, then that value will be returned. If I put a semicolon here, then what is returned is this open parenthesis, closed parenthesis. This is the return type for, it's called the unit type when it is like the null type which is returned. So we can check this. So what I'm saying is that if I put a semicolon here, then the return type of this function will become the unit type, the null type. And check that using this functions. So here the function is this. Now suppose I put a semicolon at the end of this. Save this. Then rationalize this complaint, saying that mismatch types expected I32. So you're saying that my function is going to return I32, but since I put the semicolon, and there is no return statement, the value of this last expression is a unit type. So the compiler is complaining that the type is not correct. Suppose I really wanted to do that, basically increment a value and throw it away. Then if I change this to this, then it will stop complaining. But now there's other complaint somewhere else. So here the complaint is gone, but here it's saying that the value of x, let's see what this complaint is. So this the unit type does not implement something called standard format display. So to print something, it should implement a trait. We'll come to traits later. There are behaviors which are shared between types. So it's complaining that the unit type does not implement the display. I think we can coerce the compiler to print that by saying x. And then remember I said there's a try harder kind of print implementation. So instead of putting just a opening brace and a close brace, I put that a colon and a question mark. Then it stopped complaining, but there's still a complaint. What is that complaint? It's saying that this value is not being used anywhere. So it's saying that unused value. So the Rust is always very aggressive about programs declaring values and not using it. So the complaint here, this is only a warning, it's not an error. What it's saying is that, say you're adding this x, you're adding 1 to x, but this value here, just throwing it away because you're returning the unit type. So Rust, the compiler will complain and say that maybe there's something wrong with your program because you're generating a value and not using it. So when you start writing programs, you have to, there's this wrestling you have to do with the compiler because the compiler is very demanding. The Rust compiler is very demanding about what kind of programs it is willing to accept without warning. This program will compile, but it will throw a warning that you are generating a value and throwing it away without using it. So the question was that can the type be inferred for a function? I think that cannot be done because the syntax would be incomplete. So the function. So the question was, can I not specify the type of a function? So there is a way. So type inference in this syntax, you have to specify the type of the function. Let's see what happens if I remove that thing. Maybe it will infer it. Let's go back to the old version. So this is the old version. It said increment x and just without a semicolon we are passing it to that. So what happens when I remove this? So it is complaining that so it's basically complaining that expected unit type and found I32. So if you omit the return type in a function specification, the compiler will assume that you will return the unit type. So but what we are returning is an I32, so it is complaining. Any other question? So the rationalizer is your friend. So you know, if you like Emacs or Win, there's a way to install rationalizer. It's called the language server protocol. You can install that in any of your editors. Or VS Code also has plugins for Win and Emacs. So I would definitely recommend you to, if you're trying to write Rust programs, always have the rationalizer on so that it helps you a lot in the beginning to figure out what errors you might be having in your programs even without compiling those programs. So let's talk about control flow. So far we have seen functions, some data types, variables. Then most programs need some kind of conditional control. So the if statement, straightforward. If write a condition, this is a modulo division. So the remainder when number is divided by 4, if it is 0, then do something. Then the else if has the word else space and if, and finally you need an else statement. So the else ifs are optional. The else is also optional, but this is the syntax. There's nothing surprising. But the if statement can also be used in a let statement. So the let statement was for defining variables. So we can combine that is we can assign a variable conditionally. For example, so here I have a condition which is true, it's a Boolean. So this let statement is saying that I'm assigning a variable number but the value of that number is, if the condition is true, set the value to 5, otherwise set it to 6. And note that here there is no semicolon at the end of this 5 here. If I put a semicolon here, then the type of number will not be integer, it will be the unit type, because an expression with ends with semicolon, it evaluates to the unit type.
So in that case, inside the curly braces, I put like say 3 statements together and another statement goes semicolon.
Yeah, it's fine. So the question was that can this be a very complex block? It can be. The final expression without the semicolon will be assigned to the number. But all the branches have to have the same type. So here you can't return number in one and string in the other, because the program, if condition, here if the condition is true, it is returning an integer. If the condition is false, it is returning a string. In this case, the compiler cannot figure out what the type of number should be. So in this case, it will not work. So this code will not compile. All the blocks in this if-let statement should have the same. All the branches should return the same type. In while loop, again, nothing surprising. I have a syntax is very similar to what you see in most programs. While there is no requirement for those parentheses you might see in other languages. While number is not equal to 0, then open a curly brace and close a curly brace and do something there. For loop, there are many forms of for. So if you are familiar with C, you have for int I equals 0, I less than something, I plus plus. So first has a slightly simpler syntax. It just says that for I in 0 to 4, this means that it goes from 0 to 3. So 4 is not, the outer limit is not included. If you want to include the outer limit, then you just put an equal to sign there. If you want to include the upper range, you want to go from 0 to 4, not 3, then just put dot dot and then equal to, then it will go to 4. There's some syntactic sugar to make life easier. And also you can, for also supports something like iterating over elements. There is for A is an array, for element in A, print its value. So here, I mean, you don't have to create a for with an integer and access each of the indices in the array. This element in A will work. There are some issues which might arise. I will come to that. Issues related to ownership. I'll come to that later. But these are just various forms of for which are available. Let's look at an example. Let's take the Fibonacci sequence example and see how to use whatever we have seen so far. So what is the Fibonacci sequence? You just have a sequence of numbers. The first two elements in the sequence are 1, and then the other elements are the sum of the previous two numbers. So like this 1, 1, and then 2, 1 plus 2 is 3, 2 plus 3 is 5, and so on. So let's do some first attempt. So the first attempt is I have a function n is 10. I'm printing the 10th Fibonacci number. This is a recursion form. So it takes, again you have a function, it takes an unsigned 64-bit integer as input, output is also an unsigned 64-bit integer. If n is 1 or 2, that's the base case, just print 1, else print the Fibonacci value of n minus 1 plus n minus 2. This is a simple recursive implementation using if conditions. You can do slightly different using match statement. So match is also a form of control flow. So what the the syntax is match n, then you can have multiple conditions. Here the syntax is 1, if the value of n is 1 or 2, the single line is a single pipe is syntax for or. If the value of n is 1 or 2, set it to 1, otherwise this underscore means that it's a wildcard. This means that if it is not 1 or 2, the match will execute from top to bottom. So if this did not get matched, whatever be the other value here, just run the recursive step. but both of these implementations are easy to check because they're very similar to the formula, but they repeat computations, because when you are computing Fibonacci of n-1, you will also compute Fibonacci of n-2 in the recursive call. So this is not efficient. So let's try a non-recursive implementation, just the iterative implementation. So again, you have a match, base case you get, and if it is a wildcard, then you run a loop from 2 to n. I have the current value is 1, previous value is 1, and the sum is 0, and I run something n-2 times, and I calculate the value of the Fibonacci sequence. One thing is that since the Rust compiler complains about unused variables, I put an underscore here. So an underscore before a variable name means that that variable is telling the compiler that I'm deliberately not using this variable. I think you can even remove the I and just put an underscore here. This is just a hint to the compiler that don't complain about this I being unused. I'm deliberately not using it, I'm just using it as a loop counter. So this looks fine, but it is not as easy to check as a recursive example, because there is a loop here. The recursive example had this nice form which is similar to the formula. Suppose I wanted to test this implementation. So this allows me to introduce something called unit tests. So suppose you have some programs you write in Rust and you want to test them. So unit tests are simple tests for checking functionality of small parts of code. Suppose you have a function and you just want to check that function. You can use that, use unit tests. And the nice thing about Rust is that the unit tests can be included in the same file in which the function was defined. Sometimes the unit tests also serve as documentation, because just by looking at a test, you can figure out how the function should be used. And the cargo command, which is build and package manager, also is a test command. So you can run the tests which are defined in that, run the unit tests which are in your file using the cargo test command. So let's see how to, let's look at the syntax of unit tests. So you have this, so you have main, and I've snipped out the main, and then you have the non-recursive Fibonacci, I've snipped that out, and then I have this test code here in the same file. So first thing to note is that this CFG test, it's a configuration. CFG is short for configuration. It's just saying that please configure, this mod stands for module, please configure the following code as a test code. So don't include it in your binary. In case I'm going to ship a binary, then I will not include test code in the binary. So this configuration file tells the compiler that what is going to follow is test code. And then there is a mod is for module. So in this file, I am defining a module. A module is like you can think of it as a package of code, and we are defining a module. The script test is just the name I gave. So I'm saying it can be any string here. So the module fib test is going to contain Fibonacci tests. And then I want to test the code which is in this file. So I use this syntax use super : and star. So what this does is that in this module fib tests, please import all the code which is present in the parent module. So super stands for parent. So this parent module has the main function and the Fibonacci non-recursive implementation. Please include that because I want to test this function. And then there is another configuration syntax. Tests will be just functions, but you have to prefix them just before the function starts. You have to put this string here, hash, and the pound symbol, and then square brackets and test. So whenever there can be many other helper functions here, but whenever the compiler sees test in a module which has been configured as a test module, it will interpret this as a test and it will run this when we invoke cargo test. And there are two. This test is going to test the base cases. So there are two base cases. When the input is 1, the output is also 1, and the second Fibonacci number is also 1. So we are just testing the base cases. And the syntax, this is again a convenience function. It's going to assert equal of the left hand side and the right hand side. That is, there are two arguments to assert eq, and it will check that those two are equal. Oops. So this is the, I have a function, the main function is there, then the Fibonacci non-recursive implementation, and then I have the whatever code I just showed, the test module with the two test cases. So I can run cargo test base, and it says, let me bring it to the top a little bit. So it says running zero test, but there is finally running one test. So there are the Rust compiler or the cargo tries to find tests in many places. So it did not run. So the unit test in fifth test is being run, but I have other files in this Fibonacci directory. But when I passed cargo test and base, it was looking for the string base in the name of the test, and only this test has that string. So it filtered out that particular test and ran it. If I remove that base, it will run many more tests. So it says like 2 pass. There are other tests which also ran, but it was also running this test. But what is the run? So it's saying test result okay, 1 pass. Now let's try to deliberately fail this test. So let me set this value to 2. So this should fail. So it fails because the base case value should be 1. So it says the left hand side expected value is 1, and the right hand side value is 2. So the left is equal to right fail. So this is an example of embedding unit tests in your code, and this will be a very common design pattern, because when you look at libraries written by other people, it is for filtering actually. I have a slide on that. So suppose so I have many test cases, and the base was the name of this test has the word base in it. So I want to filter out only that test. So filtering. Yeah, you can use that, but it will just look for any string, and suppose you have many files. Let me show it in this slide. So suppose you have multiple unit tests and you want to run only one of them. So you have, let's say you have test base cases and test fit 10. Now you are confident that the base cases is fine. I want to test only this. Then you can put test underscore fit 10, or you can just put fib, or you can put 10, any string which matches. If you even just put 10, then this will be filtered out because the string 10 is not there. Yeah, the test block. Like this. So this is an example of having multiple tests. So you have this one test, another test. Then you can selectively run the test by so cargo test, and you can specify the specific binary, but also after test, whatever string you put, it will do string matching in the name of the test, and it will filter out those tests. I'll be sharing these slides, so you can definitely look at them later. No, it's not. So the function name can be anything. So the question was that does the function name need to start with test? It can be anything, but this prefix, this attribute has to be there. The test attribute has to be, because you can have some helper functions. Suppose I wanted to test that the non-recursive output matches the recursive output. Then I can define the recursive. What I mean is that, let's see. So I have this code here, and I have only this base cases. But suppose let me go to the multi-test. So here I have the main function. It has the non-recursive implementation, and you have this test cases, right? So let's go to the recursive implementation. This one was there. I copy this. I'll put it in this test module. Now this recursive implementation, it's complaining because I'm not using it yet. Now I have not prefixed it with that test attribute, so it is not a test. So I will not run that as a test, but I can use this to check my non-recursive implementation. What I can do is, I can say I'll say that I want my non-recursive implementation to be equal to the recursive implementation. I know the 10th value of the Fibonacci, but maybe I don't know the 20th value. So let me change this to 20. And I run this test. Let me use the and it passed. So we can use helper functions. The test attribute is only for tests, but you can use other helper functions. They can be in the test module, like this case here. So here are two test cases. Those are test functions, but I use the recursive implementation to test the non-recursive. Yeah, so the question was that this recursive implementation doesn't need to be there. So the recursive implementation can be outside the CFD test also, because we are importing everything from the parent module. But then when you ship a binary, this test code, this function, which is used only for testing the non-recursive implementation, is shipped in that binary. You may not want that. So if you put it in the test module, it is not shipped in the production code. Yeah. So the question was that can test cases take arguments, command line arguments? Yeah, there is a syntax for that. I don't remember it exactly, but there is a syntax to that is, you can read command line arguments from the when you run the test. You can do that. I don't recall the syntax, but I will share a resource called Rust example where practice. Any other question?
You write the hashtag test, so inside that you can specify only one function or it can be multiple.
Yeah, the question was that the hashtag test, does it, can you specify one function or many? So this attribute is per function you have to specify. Otherwise, the second function will be interpreted as a helper function. It will not be interpreted as a test. So this is a test module, and there are a bunch of functions in it. Some of them may be helper functions, some of them are test code. So each test code function has to be prefixed with that test. Okay, so let's talk about something called ownership, which is not there in other languages, which is specific to Rust. So the thing about Rust is that Rust doesn't have a garbage collector, so Rust will free unused memory during program compilation itself. It decides when to free unused memory during the program compilation itself. What that means is that if I allocate some memory in a Rust program, and then there is a variable, let's say x, then the program is running, and the compiler will try to figure out when the x is not useful anymore, and immediately will free that. And the reason for this aggressive freeing of memory is that Rust programs consume less memory in general. They are very resource efficient. Other languages like Python and Go, they have something called a garbage collector. They will make the decision to free program memory during runtime. So the garbage collector will keep track of all the references to a piece of memory, and if the number of references to a piece of memory becomes 0, then they will free that variable. So the ownership, so then when Rust needs to decide when to free a particular variable, the ownership rules have to be easier for the Rust compiler to figure out. So these are the ownership rules which they chose. That is, each value has to have an owner, and they can only be one owner at a time, which means that when you assign variables, the owner of that variable may change. And when the owner goes out of scope, the variable will be dropped or free. So once a variable is dropped, if you try to access that variable, then you get a compiler error. So Rust will decide whether your code satisfies these ownership rules during compilation, so to ensure that there are no errors during runtime. Let's look at an example. These are very abstract. So it can be tricky for allocated variables. What are allocated variables? So the following program compiles, not a problem. So it's a simple program. So x equals 5, it's an integer. Then x1 is equal to 5, x2 is equal to x1, and then you print both of them. Then this program also compiles. So S1 is this is called a string literal. Then S2 is the same string literal, and you're printing hello hello. But the following program will not compile. So this S1, now instead of string literal, I'm creating a new variable. This type is a string type. This is an allocated variable type. A string from hello, and then I'm assigning S2 equals S1, and I'm printing that. So this program will not compile. So what is the compilation error? So if I run that program, I get a huge compilation error. Let's break it down. So the first one it says is that move occurs here. So when S1 equals move occurs here because S1 has type string, which does not implement the copy trait. So I'll explain what that copy trait is. And then the value of that string has been moved to S2. So I said every value has a single owner. So S1 was the owner here, then S2 becomes the owner. And later I'm trying to print both S1 and S2, but the S1 variable has been dropped. So the value borrowed here after move, it is already dropped. So what the compiler is offering a hint, it's saying that please consider cloning the value, that is making a copy of the value. So I'm sure you have a lot of questions about all this. So first, what does it mean to implement the copy trait? So first, complaint was that the string does not implement the copy trait. Copy trait means that it's a deep copy. So if something implements a copy trait, then x equals y will be an exact copy of y. I'll show why string does not implement this. String does not implement copy because it's expensive. If you have a long string, if every time the string is assigned, if you make a copy, it's expensive, so it's not done by default. But if you actually want to do it, the syntax is that let S2 is equal to S1 dot clone. This is a deep copy. String assignment actually does something called a shallow copy. I have a picture in the next slide. But then you might ask that why did the following program not give an error? Because it said this also looks like a string. S1 equals hello and S2 equals S1. This one does not give an error. The reason for that is this hello is a string literal, so it is not an allocated variable. Its value and size is known at compile time. So this string will be directly embedded into the program binary, and they are hard coded into the program binary, so there is no memory allocated which needs to be free. So let's look at some pictures about that string, capital S string. So when you do this, what is actually happening? When you write this S1 is equal to string from hello, first an array is allocated. It has 5 locations where the 5 characters hello, the characters of hello are allocated, and the value S1 is actually a pointer. So it has a length 5 and this has a capacity 5. So string is an allocated variable whose size can change during runtime. So it's allocated in memory. If you understand stack and heap, this is heap allocated variable. And this S1, when you write this command, this statement S1 is equal to string from hello, then this S1 points to this allocated memory. Then when you assign it, when you say S2 is equal to S1, then the S1 will be dropped, the pointer goes away, and S2 is a pointer which is a copy of this. S2 has the same components as S1. It has a pointer, but now the pointer will point to that array, and it has the same length and capacity. That is, the current length is 5, capacity means that how much more it can accommodate. So this is what S2 equals S1 means. And the reason that program gave an error was that we were trying to print both S1 and S2, but S1 was dropped by the program because this memory is now owned by S2. S1 does not have ownership of the memory, so it can't print the contents of that. So to avoid ownership errors, you can always clone. So you can do a deep copy, S2 is equal to S1 dot clone. But you can also use something called references. But this cloning is expensive. If you have a long string, you can imagine that copying means that you're creating 2 copies of that array. So it's an expensive operation. In many cases, you can use something called references to avoid these ownership errors. But any questions before I show you references?
So string literals and the string concat are they treated as different data types? Like if you're trying to concatenate, for example, can that be done? Or
yeah. So the question was that string literals and the strings are definitely they different data types? Yes. So they have different. So if you want to concatenate, then the string this is a type. This has functions which allow you to concatenate string literals, but there is no direct syntax for concatenate. They are different data types. You have to call a method to do the concatenation.
But then if you have like say 2 string literals, you can discuss this.
If you have 2 string literals, so string literals are actually immutable, so it might complain about it. So what is the value of that cannot be another string literal, or maybe it can be, but I'll have to check you can try it in the compiler. Any other questions? Yeah.
If we write S1 equal to this or S1 equal to directly the literal hello, what is the difference between the two statements?
The question was that what is the difference between S1 is equal to string literal hello and S1 is equal to string from hello? So string literals are immutable in the sense that their size cannot change. So you may have programs when you want to maybe append world to this. You want to change you can mute S1 and you want to change the value of that string. When you have a string where the length of that string may change, then you should use this capital S string. If you have a string whose length will not change, it is like maybe like some information statement and it's never going to change, you can use string. Yeah, so this one, the ownership rules was every value has to have a single owner. So the string literal S1 was the owner, and in the previous version when S2 is equal to S1, S2 became the owner of that. So then then S1 was dropped because it is not being used in the rest of the program, and that's why this print statement was completed. Yeah.
Can't you let mute S1 equals the string literal?
String literals are immutable, so you can try writing that. I think it may complain about that.
It's a one string longer than 50.
Okay. So the type of string literal is this. So if you want to, so the rationalizer has populated the type. So there is ampersand str is that. So if I put mute, it will complain. Oh, it doesn't need to be mutable, but it's allowing that. Literals, it might work. You can try that. Maybe mute or something. So the thing is that the type of this is it's a reference. So the string literal itself is immutable, but the pointer to it can change. So the literal itself is immutable, but the pointer is changing. So this ampersand actually is for reference, which I have some slides about. That is the next topic. We have break at 10:30, so let's. I know you guys are getting restless, so let's just finish this a few more slides and we can take a break. There's another ownership error I'll show you, which is about a function. So what is happening? I have a string, and then I call a function called calculate length. and the calculate length takes the string and it returns a u size, which is an unsigned integer, 64-bit unsigned integer, which is the length of that. It just calls this function, which is a built-in function of string, s.length. Now this program will not compile, it gives an error because what is happening is that when this calculate length is called with s1 as an argument, calculate length takes ownership of that s1. So this s is being assigned to s1. So this function takes ownership of that string, and then when you try to print s1 after this, it complains that the value has moved. This program will not compile. So what is the again? So parameter s is taking ownership of that s1, and then s1 is not accessible anymore. So one way out of this is to use something called a reference. So references are like pointers. They allow you to access data values without taking ownership. So if you know that you don't need to take ownership of that some value, then you can use references. So it is as simple as prefixing an ampersand symbol to the variable. So like for example here, now the signature of this function has changed. Instead of just string, there is an ampersand string. So this calculate length takes a reference to a string as an input. So and also you are passing the reference as the input here. So s1 was a string. Instead of passing s1, you are passing ampersand string. You are giving the compiler a hint that this function doesn't need to take ownership of the value. Please retain ownership with the original variable, and I will be using that variable later. So this like every value has to have a single owner. The reference is saying that s1 can continue to own the data. You don't need to pass the ownership to this function. So that is a hint to the compiler. Yeah. So the thing with references is that you can have multiple immutable references to a variable, but you can have only a single mutable reference. So I will show you the difference in the syntax. So just before I go, so creating a reference is called borrowing. So the ownership rules about references work like I did not put it in this slide. That you can have multiple immutable references. That is, you take a reference where you are not going to modify the data, then there can be multiple immutable references. But you can also create something called a mutable reference. A mutable reference is the borrowed value can be modified also, and you just have to prefix with ampersand. So there can only be a single mutable reference. So the syntax is like this, like mute s string from hello, then change the mute. What I am doing is I am appending world to it. So here this function takes this mutable reference to it. So there can only be a single mutable reference at any time, but many immutable references. I don't have an example to illustrate that, unfortunately, but we can play around with the compiler and see. Maybe one last thing before we break. Let's look at structures. What are structures? They are like any structures in any language. They allow grouping of related data. For example, here is a rectangle structure. It has a width and a height. I am initiating a rectangle, initializing a rectangle with width 30 and height 50. Then I print the area of the rectangle. So syntax for accessing members of the struct are dot. Just put dot and the name of the member. Nothing different from what you have seen in other languages. But you can also associate methods which are structured. So Rust doesn't have classes. So if you are used, yeah. This mute here? Okay. Okay. So this push str is it's a function which is defined for the string type. So if you're wondering about what some piece of code does, you can always go to Rust Analyzer. That is, you go to VS Code, push str, just put your cursor on that, and it will immediately pop up the help of that. It says appends a given string slice onto the end of this string. A slice is like an array, so you can, and it also gives you an example. So this documentation is actually from the Rust official documentation. So even when you write your own code and you want to publish it in as a Rust package, you can create such documentation by just putting some comments above your function, and they will show up in these hints. Some string is a mutable reference to a string, and I'm pushing. So if you see this, some string is actually a mutable reference to a string. It's not a string, but it's like a pointer to a string which we modify. So as I was saying, Rust doesn't have classes. Like most languages, many languages have classes. It only has structs. So suppose I have some data, but I want to associate some functions with that data type. Like suppose I have student and I want to write a function that calculate the CPA of the student. Then we need some way of linking methods to a data type. And you can. The difference between a function and a method is that the first argument for a method is always self or a reference to self. For example, we just saw this push string. It's a method to the string type. So if you see, the first argument to push string is a mutable reference to the self. So the difference between functions and methods is that the first argument of a method will be a self or a reference to a self. So let's see the rectangle structure with methods. So you have the usual structure as before. What this derived debug does is, if I want to print this, right, the derived debug is the compiler will automatically figure out how to print this rectangle. So it is again, debug stands for how should I display this. So we are telling the compiler, can you please go ahead and derive the printing some printing function for this rectangle. You can overload that function, because you can write our own, but it's a convenience. Here, so the syntax is, you put this IMPL, which stands for implementation. In an implementation of rectangle, I'm defining a function, and that becomes a method, a function method. So function area, reference to self, and then it is going to output a UN32. And the way to use it is, you define a rectangle and just get dot area. So you define a rectangle rect1, and then previously I had rect dot width multiplied by rect dot height. Here I just say rect dot area, and the self means that the dot syntax allows you to call methods which are defined for that particular structure. And you can have multiple methods in a single implementation block. Here I have area, and I also have a function, not a function, a method called square, is square. I'm checking if the rectangle is a square. I'm checking that the width is equal to height, return a true or a false. You can also have multiple implementation blocks. So it's not necessary that there will be a single implementation block for a structure. You can spread out your implementation over multiple files. So here is the first implementation block here, where I'm defining the area method. In another implementation block, the syntax is the name of the structure has to repeat. So IMPL structure name, and you check whether it's a square or not. Okay. So I think I think we'll take a break at this point. I can take questions if there are any. Yeah, that's what we did here.
So, is there any difference between this and splitting it across?
Yeah, the question was, is there any difference between splitting the implementation functions over multiple implementation blocks? So sometimes if you have a structure which has a lot of methods, then you may want to group the methods by some kind of type of method. So then you may have multiple files where you will define one implementation block with some functions and another file with implementation. Just for convenience. Any other questions? Yeah, so it does not matter where they're different. They're all called using the same syntax. Dot. Okay. So we can take a break, 15-minute break. We have to give up this room at 12 p.m. because of the e-summit activity. So please come back by 10:45. There's I think tea and some tea and coffee outside. And let's come back at 10:45 in this program. And the possibilities are BTech, MTech, and PhD. So if the degree is BTech, then I print that he's a UG student, and it's MTech or PhD. Again, that pipe operator is for or. Then I print that he's a PhD student. So you can use enums like this, but enums also can have values. So this I have an enum now, which is a campus address. So it's either a hostel, and the hostel has a number, and it's an unsigned integer. And or it can be a building, maybe it's a faculty or a staff member, so their building has a name, which is a string. So now this enum, even though there are two possibilities, those two possibilities can also contain some associated data with that campus address. Then I have a campus resident who has a name and they have an address, and that address is of type campus address, it is an enum type. Then I can match on the address, so I can create a campus resident, John Doe, who lives in hostel 16, then I can match on the address and say that if the address is of type hostel, then notice the matching. When I match on this, I'm matching with hostel, and the n, that variable n is bound to the hostel number, then I can print that this person lives in hostel n. And similarly, if that c dot address matches the building, then that whatever variable I put here, that s variable will capture the variable of the building name, and you can print that, you can use that later. So again, some syntactic sugar for making code shorter. So let's talk about generic types. So here is an example of 2D point. So generic types enable code reuse. You might have seen it in other, I think they are called generics in C++. Yes. Yeah. So the question was that does the match statement evaluate all the branches or only one? So it will evaluate the first one which it matches. Yeah, it's like it doesn't fall. So there's no, not like in some languages you may see like a break or something, right? We don't need that. So the other branches are not evaluated. Whatever matches first will be evaluated in this. So generic types is suppose you have suppose these two structures for a 2D point. So x and y coordinates. So I have an integer point and a floating point. So the integer point is signed 64-bit integers x and y. Here floating point 64-bit floating point. It seems now if I were to write functions for this, those functions, many of the functions may have the same structure. So can I somehow write a function once and use it for many points of this form? So you can combine these points into a generic type. So here I have written a structure, but now that structure has a type parameter. The type parameter is t, and I'm saying that x and y are both of type t. So this type abstracts out the features of both int point and float point. If I initialize point with instead of type parameter t, I put I64, it will be an int point, and otherwise it will be a floating point, a float point. So let's try to make this work. So here's the first attempt. So I want to do square distance. What I'm doing is I'm defining a point. It is a generic type. There is a type parameter there. Then I'm implementing a method which should work for any type parameter. That is, now the implementation syntax, it slightly changes. I have to specify the t, the angle brackets t after the implementation. Then I say that square distance from origin is again it's a method, so it takes a self as an input. Self.x square plus self.y square, that is square distance from the origin. And suppose I try to compile this. I say first attempt because it is not going to compile. So here I create a point. Point P is make it bigger. point P, P is a point with coordinates x, y as 1 and 5, and I try to do this square distance. This will come in. Let's see what the compilation error is. So here rationalizer is already showing me the error. So let me point at that and see what it is. So rationalizer is saying that I cannot multiply t by t. Consider restricting type parameter t. So it says that considering restricting type parameter t to std ops mul. So now the problem with this program is that I'm saying t can be any type. I'm creating a point of type t, but what if I put t as a string? I cannot multiply a string with a string. So there has to be some restriction on that type which can be put in that point. It has to be something which supports multiplication. That is what this error is saying. Because you're multiplying, I cannot multiply a type t with t. So, so what is the restriction which I need to put on t? The restriction is something called number or num. So we need a type. Because I am doing squared distance from the origin, I need to be able to multiply that type and add that type. So the type t has to support additions and multiplications. So that is captured by something called the num trait, which is provided by Rust in the standard library. And to add this trait, we have to add a dependency. So far all the programs we had defined, there were no dependencies. In that cargo.toml file, there was zero dependency. They didn't put anything under the dependency section. But we have to add this num traits trait here. So let's see, and the way to add dependencies is cargo add num traits. Let me show you how that works. So here, I may have already added. Let me remove that and then add it back. So here, this cargo.toml has this num traits, right? Suppose I delete this. I say cargo. Now the cargo.toml file has no dependencies. Now I just say cargo add num traits. Then there is a website called crates.io which is maintained by the Rust community. So that has all the packages which have been published by people, and it is automatically downloading from there. So you need internet access for this to work. It is downloading from there and it's adding that. Now if you look at the cargo.toml file again, if you notice under dependencies, now this num traits thing has appeared. So num is defined in that num traits package. Now the cargo.toml, as I said, will have this. You add this because the reason I showed you that cargo add is that what should be the version number. So Rust will figure it out automatically and fill that in for you. Now let's try modifying the point definition. So we have to use that. We have to bring that num trait. A trait is like a behavior. We have to bring it into scope. So we have to use this syntax. Use num traits. This syntax here. And then now the implementation of square distance is that I have a point which is a two-dimensional point here. But I am restricting this implementation to say that this function is valid only when this t which I put in satisfies this num trait. That is, it supports additions and multiplications. If I were to implement point with string, if instead of t I just put string, then it will not work. So that is the second attempt, but still there is something remaining. So let's see what happens when, let's look at point 2 here. So this also doesn't compile, it's showing me some red squiggly lines here. So here it is saying that there's something about ownership. It says cannot move out of self.x, which is behind a shared reference. Move occurs because self.x has type t, which does not implement the copy trait. So we have to implement the copy trait, but then how do I implement that? I don't even know what the trait is. luckily for us, Rust can implement many traits automatically. So let's look at the third attempt. So there's only one line which has changed here. This instead of specifying the type P as just num, I'm specifying it as num plus copy. Plus here means that I want P to have two behaviors and the union of the two behaviors. One behavior is it has to behave like a number. The other behavior is that I want it to be able to be deep copy automatically. So when I do the squaring here, self.x into self.y, the self.x is taking ownership. This multiplication here, the ownership is being moved here, and the second copy of self.x is not available. So that is why it was complaining. But if this copy trait is added to T, then that is any object which satisfies, which automatically has copying enabled, then the square distance will work for that. And in our example, we are using integers. Integers by default have the copy trait. We don't have to implement that. So this will compile and it will print the distance. You can check what your attempt is. It's 0.3 has only num and copy. If you were to run I'll go run 0.3, next one is then it says distance is 26, so 5 square plus 1 square is 26, so you get some answer. So this, so you have to listen to the compiler. So the thing with Rust, which you may not experience with other programming languages, is that the compiler is very specific about ownership, the compiler is very specific about the types. So when you write some program and you compile it for the first time, you are going to get some compilation errors. Then slowly you have to figure out what the compiler wants, and most of the time it will give you a hint in the compilation error, and sometimes there is even a link in the compilation error, so you can use that to figure out how to solve the issues. Any questions about this thing? So you're talking about enums, right? So this here is another generic I tried that, but that doesn't work. So the question was that can you use a reference to instead of copy? Yeah, I'll have to try that. I remember trying that to see if I can avoid this copy, but I couldn't figure it out. The thing with integers is that they already implement copy. So in integers, they're basic data types, so the shallow copy and deep copy are the same. So you don't gain much by going to that extra mile of doing the reference. So this option is, so Rust doesn't have null pointers. So this option is a way to capture or model a value which can have either a null value or a not null value. So this, it is a generic type, but it's an enum. Enums can hold data. So here it's saying that this option T means that either it's a null value as in none, or it is some value. So sometimes later when we see vectors, there is some method to find a particular value in a vector. Let's say a vector of integers. I want to check if find the location of the integer 20. Then it will search the vector, and if there is the integer 20 doesn't exist in the vector, then it will return none. Otherwise, it will return the location of the integer. So when you have methods which can either return a null value or a correct value, then the return value of those methods is usually as option. It is a very prevalent data type. You will see it in many places. So is result. What is result? So here it is difference between null and something. Here result is it's going to model a variable which can take two values. One is correct execution or error. So sometimes the error can be modeled as a null value, but sometimes the error itself can have multiple types. So here this error will capture that the value of the error, and if you get a correct answer, then OK is the value of the correct answer. So this is also an example of two types. So generics, when I showed you the point example, there was only a single type key, but there can be any number of generics. So here there are two generics here, generic variables, T and E. T is the type which is going to capture the correct answer, and E is the error type. So it's used to model the result of an operation which might fail. And like I said, E is the success value, T is the correct return value of success, and E is the return value on error. Here is an example. So suppose I open a file, hello.txt, and then I store the result into greeting file result. Then I will match on the value of greeting file result. If the matching value is OK file, I'll return the file. Otherwise, I will panic. Panic is the program will exit with this error message. So this greeting file result, which is the result of this file open. Now the opening of the file, maybe the file doesn't exist. Then it will throw an error. But if the file exists, you will get a correct answer. So the result captures both these scenarios. If the file exists, then you will get back OK file. Or if the file does not exist, then you will get back this error, and then you can print the value of this. What is the problem? Does the file not exist, or the file too big? There can be many issues why the file exists, the file opening failed. So that is one useful case of result. And the result is also used for something called propagating errors. So far Rust seems like it is just a different syntax for the languages you know. So why is Rust preferred by many developers? One is of course the memory ownership rules, which make it easier to write memory safe programs. The other is the programs are typically shorter. Like for example, let's consider this case of propagating errors. So suppose I have a method which can have an error, which can return an error. And in many cases, you want the method caller to handle the error, because the caller of the method, suppose I'm opening a file, I may have more context about what I should do if the file opening fails. So this principle is for propagating the error. So you want the error, if you have a method for opening a file, you don't want that file opening method to handle the error. You want to bubble up the error to the caller and say, let the caller figure out how the error should be handled. So here is some syntax for, here is an example of a method which has errors, which can have errors, and the errors are being returned to the caller of this function. So first notice that this read username, this read username from file, its return value is result. So it either returns OK string or an error which is an IO error. It has two return values. And first I am opening a file, it's hello.txt. Then I match on the username file result. I open this file and that is stored in this username file result. I match on that. If the file was opened correctly, then I return the file. Otherwise, I return the error. Now this return statement will jump out of this function, and the type of return is in this case is error, right? So that is the type as is IO error. So we are returning error here, so that matches that. But if it is okay, if the file opening succeeded, then I am continuing. There is no return here. There is not return file. This is file. The username is this file value is assigned to this username file, and then I continue. Then I calculate a mutable variable, a new string. Then I am reading this file into that string. So the read to string takes the mutable string as an argument, and the username, the file is being read into that string. Again, this can fail because the file may be too big to fit in that string. Maybe the computer runs out of memory, it's a 1 terabyte file and you have only 8 GB RAM. So again, this can also fail. So if it succeeds, I return OK username, and if it fails, then I return error. Now this is the last statement in the program. So the return type of this last statement is method, sorry. So the return type, no semicolon here. So the expression of this match statement is either going to be OK username or error E that matches the return type of this function here. So either OK string or error IO. So this is one example of error propagation, but this is a bit verbose. So what Rust gives you is it gives you a shorter syntax for error propagation. It's called the question mark operator. So this is the same function as before. What has changed is I put a question mark at the end of this file open. So the return value of this file open was some result string or IO error. So I put a question mark, then that is the same as the same effect. So if this errors, then it will immediately return the error. If it passes, then the username file will be populated with the name of the file. Or it will be not the name of the file, the actual file. The file is being opened. Similarly here, I am creating a string and I am reading the file into that string. I put the question mark there. Then if it passes, then username will, so this mutable string will have the contents of the file. Otherwise, if there is an error, then it will return the error. So it's again syntactic sugar for making programs shorter. So this program is definitely shorter. I put some spaces for readability, but just like 3 lines compared to this program, where I had to write a lot more code to do that error handling, where I had match, and then if it is OK, then return, and then error, and so on. All that is being replaced by a single this question mark operator. So some syntactic sugar for error propagation. So any questions? Yeah. So the question was, what do the file and the E contain? So this this username file result is the result of this open, right? So I will just open that file in Rust Analyzer so you can see the return type of that. So error propagation. So this file open, its return is it's either a result, it's a result of, so you see this type here, it's a result which is file or error, and result we said is an enum which contains OK file or error. So when I match on username file result, it can have 2 possible values, OK file or error. So this file variable is being bound to, if it is OK file, the value of that file, and if it is an error, then E is bound to that error. Any other question? Okay, so let's discuss traits. I already said copy trait and num trait already. So what are traits? Suppose you want to define your own trait, because this copy and num were built-in traits. So traits are a way for different types to have the same behavior. It's like so it's just a collection of function declarations. Let's take this example of area trait, which is I'm defining this one, so it's not a built-in one. It has a single function, and that function takes the object which which is going to implement this trait, this behavior, and it is going to take a reference to that object and is going to return a 64-bit floating point number. And notice that there is no implementation here. It is just the function declaration is ending. So you just have function name, parameters, return value, and colon, semicolon. So what this means is that any data structure, like a structure, any struct which implements this state has to implement the area method. So let's look at an example. Here I have the area trait. It's a pub, is again some keyword I'm introducing. It's a public trait, so it is available to functions which are outside this file. Then I have a rectangle structure, and I'm implementing area for the rectangle. So the rectangle has width and height, so the implementation is self.width into self.height. So this is just a simple implementation of the area trait. But multiple objects there can be multiple trait implementations. So now I have a area trait, I have rectangle, and I have circle also. So the area implementation for rectangle is this as before, but you can also have the circle implementing the area trait. You have the function of the same function area. Now the circle has a single member called radius, so then the area is pi into r square. So this way you can have multiple objects which share the same behavior. So in this case the objects are rectangles and circles. They can calculate areas for you. So I discussed arrays. Vectors are yeah, go ahead. It's just an example. So in the sense that in practice, for example, we saw the num trait, right? So that was definitely useful in the sense that all numbers like integers and floating points should implement the number trait. So area is just an illustrative example, something which can fit in a slide. So in the sense that what would be a better example? So suppose you have campus resident as a structure, then you can maybe have the address of that person. So has address could be a trait, and then that in has address trait you could have, let's say that print address could be a function. So every campus resident structure should, or a type of campus resident should implement the address of that. So it's some way of capturing common functionality between objects, between structures. So in if you learned C recently, you would have noticed that it has arrays, but if you had to do anything with arrays, there's a lot of work. Vectors are dynamically sized arrays. They are very useful in Rust, and they are used everywhere. So they just think of them as lists which can be sized differently, and they should have the same type objects. You can't have different types. There are multiple ways of defining a vector. Here I am defining an empty vector. So the syntax is mut. This is a mutable vector, capital V vec, and then this is a generic type. So a vector can have different kinds of objects, maybe integers, floating points, strings. So this syntax is saying that this vector is going to have signed integers which are 32-bit, and right now it's going to be a new vector, so it's empty. It's an empty vector. Then you can push 10 and then 11. So these now the vector will have two values, 10 and 11, and then you can print it. Again, you need that this hint to the, or some encouragement to the compiler to print this vector. You can also define a vector. This was a mutable vector, so I'm overwriting it. I'm overwriting it as the vector 4, 5, 6. This is the syntax for defining a vector when you know the values in that vector. This is small v. Notice the small v and the exclamation point. So this syntax will initialize the vector with 4, 5, 6. But suppose you want a long vector where you want the same value to be repeated. So this syntax can also be used. This will create a vector of length 5 with all 10s. So it has 10, 10, 10 in the 5 10s in. So sometimes you may want to initialize the vector with some default values, but you know the length. You can use this syntax to initialize that. Accessing the vector elements, it is like array syntax, zero indexing. So v0, v1 will access the first two elements. You can also access a vector using a reference. So here the syntax is, I put a for I in ampersand v. This will mean that the reference to these elements will be accessed. You can, I think, I don't know if I have that in the. Oops. Yeah, that's on. Yes. I think I copied some files by mistake, but I fixed that later. So I don't have that example here, but this you can try the syntax in a file to see what is the type of this I. The type of this I will be reference to this integer here. You can also use a mutable reference. So this for I in mut v, then what this means is that I can, so the star operator is new. What this is doing is that I'm taking a mutable reference to the elements of the vector, and then I'm adding 50 to each of those elements. So after this for loop runs, you'll have 150, 82, and 107. A lot of many useful methods. I'll share these slides. You can look at this the standard. That is the official documentation of Rust. It has a lot of nice methods like you can calculate the length. You can pop will remove the last element. Clear is for clearing the vector, that's emptying the vector. You can check whether it's empty or not. You can resize the vector, and you can resize with the default value. That is, you're resizing the vector from vector size, let's say from 5 to 10. If you want to fill the remaining values with some default value like 0, you can do that. You can truncate a vector. You can deduplicate. If you have repeated elements in a vector, you can deduplicate the repeated elements of a single command. Then you have something like retain. Retain, I have an example. So, for example, here, suppose I want to have a vector. It's a mutable vector. It has numbers 1, 2, 3, 4. Suppose I want to retain only the even integers. Then I'm passing something called a function. This is a syntax for something called an anonymous function. The syntax is you have these two pipes, and then you have ampersand x, so this is taking a reference, and it is this function is called a predicate. So the predicate is that x when it is modulo 2, x modulo 2 should be 0. That is, this predicate will be true when x is even. So this command is saying that please retain only the even integers in this vector. So later you can check that this vector has only 2 and 4, 1 and 3 have been removed. So you may encounter situations where you have some vector of values and you want to filter out some values. This is some nice these functions which help you do that. There are many other functions you can check in this official documentation. Any questions so far? Yeah.
Last line, how are you comparing a vector with an array? Yes,
Oh, okay, yeah. Maybe it is Rust did some inference. Let me check. Did this run? Yeah, it did pass. Let me just check if this code is being executed. Or okay, failed. So maybe there is some Rust inference happening here. How do I check?
failed because you added.
Yeah, I added, but I want to know the type of this. It's so I guess AccessingTriple is doing some checking here. So here you can notice that A has an array type, and then vector is has this vector type. So maybe it is the equality has been implemented for vector between arrays and vectors. Let me check. The way to check that would be it allocates a vector and from some array. So maybe there is AccessingTriple is doing some magic in the backend. It's a good question. I mean, why?
Somewhere it says you can compare a slice of an array with a slice of a vector.
Okay, so maybe that it is. I do not want to discuss slices, but maybe that there's some implicit conversion happening. So let's say if I change this to this should also work. That also works. So maybe some implicit conversion happening that AccessingTriple. Bring it out of the slide.
So, next question, if I want to take it as a function of two variables, we come under the second in the commas, and it's ampersand x comma ampersand y.
Oh yeah. So the question was that what is the syntax for anonymous functions with two variables? Yeah, you can. I think you can use ampersand x comma ampersand y. That should work. You can try it. I mean, otherwise you can use tuple. If it is allowing only a single variable, just use a tuple. So iterators are they allow you to perform a task on a sequence of items. They help you shorten your Rust code. So you should definitely spend some time understanding iterators. Whenever you find yourself writing a for loop, check if you can express the code using an iterator instead. And the iterator is actually a trait again, and only the main function it needs to implement is this next function. So given a collection, you should be able to get the next item in that collection. Like for example, vectors have iterators. So this I have a vector 1, 2, 3, and this v iter is iterated to a vector. And this iterator, that trait, it has a sum helper function. So suppose I wanted to calculate a sum of some integers which are present in a vector. Typically you would reach for a for loop and say for I from 0 to the length of the vector, let me add up, then I have to initialize the sum to 0 and then do some work. Here there's a nice utility function. Given the iterator, you just say dot sum and it will calculate the sum of that vector for you. Let's take the example of course credits. So suppose you have this courses which are either core or elective courses, and a course it has some credits which is an integer, and it has a course category which is either core or elective, and I suppose I want to compute the sum of the core course credits which a student has taken. So I have a vector of courses and I want to compute the core course credits. Now you would say that okay, let's write a for loop and I will check if the particular course is a core course or an elective course, and I will add some running sum. I'll calculate some running sum. But here is another solution using iterators. So what I've done here, the first part is I just populated some 10 courses. So I have a mutable vector which is empty initially, this is an empty vector. Then I'm running I from 0 to 10, and if I percentage 3 is 0, but if I is a multiple of 3, then I'm populating C as a course which is a core course with 8 credits, otherwise it's an elective course with 6 credits. So whenever I is a multiple of 3, C is assigned to a core course, otherwise it's assigned to an elective course, and I'm pushing that C into this courses vector. This courses vector is mutable and courses.push C. So just some data, I'm just populating some data to show you how iterators work. Now here is a very succinct way to compute the sum of the core course credits. So what it is doing is, I take the courses, it's a vector, I call the iter command. Now this iter command is giving me an iterator to the vector. Then the iterators you can have something called a filter command on the iterator. It's filtering the courses in that iterator with category course category to be equal to core. So this filter function, it takes a anonymous function as a input. So anonymous function, the syntax is you have parameters and body, function body. The reason it's called an anonymous function, it has no name. They have not named this function. You could name the function outside and pass that function, but this is convenient syntax. So this function takes a single variable C, and it's checking if the category of that C dot category is equal to course type code. So at the end of this filter method, you have iterated through the courses and you have filtered out only the core courses remain, and then I will map now. But the iterator is still the type courses. When I'm mapping the courses to the credits, and then finally I'm calling sum on the credits. So at this point, after map runs, I'll have a vector of or an iterator of integers, unsigned integers. Then I call sum on it. Then I get the sum. So again, an example of very succinct code, which is also one of the reasons Rust is popular. That logic which in other languages would require some more lines of code, we can write it in a very succinct manner. And less code also means that less code you need to test. So there was a for loop. There are many places I can go wrong. Maybe I did not initialize the running sum properly, or I'm adding it twice. If you write code using iterators, then they're less likely to have errors. It can still have errors, but they're less likely to make a mistake. This is also called a functional programming style, which is it's very common in languages like Haskell. So Rust borrows ideas from other successful languages. Any questions about this? Say that again. Say that again. So it maps the course to the number of credits. So C is a course, and let me open this in the Rust analyzer. So the Rust analyzer is added these type hints. So first courses, the iterator and the filter, it is giving a double reference to a course. But the dot is converting that reference to the actual course, so checking that the category is of code. And then this map takes as input a course and then converts it into an integer credits. So it's mapping courses to the credits. And then you sum those credits. So if I were to remove this it's complaining because the type of this is even 32, it's not. So now, so what is happening now? I just copy pasted some part of the code to show you what the type of the iterator is after the filter is run. So courses, when you convert courses a vector, when you run the iter function, then you get an iterator to a courses where the item is a course, a reference to a course. Then the filter is going to keep only the core courses. So the result of the filter is again an iterator to courses. But then if I map this, now if I add that map function here, and if I hit save, this now this iterator, even before I hit save, the iterator has changed from courses to unit 32. So maps courses to credits. Then I sum over those credits. So map is given a vector, a mapping is going to map it to a different vector. Or in this case, given an iterator is going to map it to a different iterator. Before the map was called, the iterator was an iterator of courses. If I do Control Z, notice that here it has become courses. After the map, it has become iterator of integers. So then we can sum over those integers. And suppose you wanted to, suppose you have two vectors and you want to count the number of places in which they are equal. So here, where are they equal? They are equal in the second location, and then here this location here. And I want to know how many locations are these two vectors equal. Even this can be done succinctly using iterators. So this uses some other helper function called zip. What zip does is that given two iterators, it will compute zip iter 1, zip iter 2 gives you iter of pairs type 1, type element 1, element 2. So what's happening here is v1 is a vector, that is one of the vectors that you got is hiding there, v1, and I'm converting it into an iterator. v2 I convert it into an iterator, and I'm running zip on both of these iterators. Zip will give me, it is going to create pairs of numbers like this. Zip will give me pairs of numbers like so the first 15 and 76 in a tuple, and then it will give me 23 and 23, and then 44 and 27, and so on. Then I have an iterator of tuples where all these pairs have been, all these integers have been paired together. Then the map takes a tuple as an input, and it is going to check if they are equal. If they are equal, I map it to 1, otherwise I map it to 0. Then I sum over those wherever there is ones. I have an iterator of integers. If I sum them, I get the number of matches in the two vectors. So again, some very succinct syntax for logic, which in other languages you may have to work a little harder. That's a good question. So the question was that what happens if the iterators are of different sizes? Zip handles it to the, shortens it to the shorter iterator. Let's see that. Oh, it's an iterator. So it's saying number of matches is 4. So I've modified the lengths of the vectors. Now it's saying number of matches is 4. Let's check 23, 56, 83. Then this one. Okay, now save this.
So you're in the vectors slash iterate.
Oh, okay, yeah, I think I made a recursive copy here. So number of matches is 3. So now 3 matches 23 and 83 and 56. 3 matches. So zip again, if you had to write this by yourself, then you would have to worry about the lengths of the iterators being different, because the iterator only has a next function. So the iterator will keep checking until the next works. If one of the vectors is shorter, one of the iterators is shorter, the next doesn't work, then it will stop processing. So it is a good default that if one of the iterators is shorter, then just create pairs which corresponding to the shorter one. So they are called crates. Crates are like the basic unit of a code which a Rust compiler can compile. A single file is also a crate, but you can also have other more complicated crates. Binary crates and library crates are the two different types of crates. Binary crates are executables. All the crates I showed you are binary crates. And library crates have code which is executable by others. So when you create a library, you will share it with people. Then your library, the code you share may not have an executable, but other people may build executables using these library crates. So the binary crate is just has this simple form, the cargo.toml file and source and a main. It has to have a main. A library crate will have a lib file instead of a main file. All the code will be, there won't be any executable, there's no main function. It will just have some public functions which other people can access. You can also have a binary crate. You can partition the code into, it doesn't need to have a single main file. You can have multiple parts called modules. They are logical partitions in your code. For example, here is a binary crate. There is a main file, so we know it's a binary crate because there's a main.rs. But it has these modules. Garden is a module, and vegetables is a submodule of garden. If you have a module and if this garden needs to have a submodule, then there has to be a directory with the same name, and then you have to put your submodules in there. So here is so the main.rs. The way you define a module is by having this mod garden, and if you want to use code from the garden crate, you have to say use crate is a root crate, garden, and use a vegetable submodule, and we are using asparagus from that. Asparagus is structure, so you're initializing an asparagus structure and you're printing something about that. So the garden is a submodule of, garden is a module, so it can have a submodule. The way you define a submodule is just again use the mod, but by default the code in submodules is hidden to the parent module, so you have to put this pub identifier. And the location of modules is so the way, so when in the main, when the mod garden is seen in main, the compiler will immediately look for a file which is either garden.rs or either three places actually, either in a block immediately after mod garden. That is, if I so if the compiler sees this statement mod garden, it may look for the code immediately after, in a curly braces after this, like mod tests. We were looking at test modules, like fit tests. The code was immediately after the module. So either you include the module code directly in the file itself, or you put it in a file called source garden.rs, like in this case, or it can also be in a file source garden mod.rs. So the reason for these different permutations will become clearer when you start writing larger code. But when you see a mod, then these are the places you should look for. If it says mod garden, either the code is immediately in the file, or it is in a file called garden.rs, or there is a directory and the code is actually the first file you should look for is mod.rs in that directory. If you see the line, for submodules, similar logic applies. So vegetable is a submodule of garden. So when the compiler sees pub mod vegetables in garden.rs, and you look for either code in the block immediately following it, or in the file source vegetables, or in the directory, or in the file mod.rs, which is in the directory vegetables. So this is how you organize. So it's the name of the directories is important when you organize your package into many files. And the visibility of modules is code in a module is private to the parent modules by default, so you should initialize or you should prefix the modules with pub if you want it to be accessible to the parent module. And also individual structs and functions also you can keep them hidden. If you don't write this pub explicitly, it is assumed to be private. Yeah. So if you remember that test modules, sometimes we don't need to create a separate file. Test modules, the code was immediately after the mod fit test. So in some contexts, it makes sense to have the code in the same file. In the sense that if the code does not appear immediately, then you will import it from the other file. So in test modules, it makes sense to have it in the same file, so because for readability, that you have this function and immediately see how it is being used. So that's all I had. These slides are, just go to my home page and append the string Rust, and these slides will appear there. Hopefully it works. It should work. So just Rust. Yeah, it works. And I include these controls because in the mobile sometimes flipping slides doesn't work. And then the code is in this SSL GitHub. I'll just fix that. I think I did some recursive copy error. There's too many files there. I'll remove some of them. And then the best place to, all the examples I showed, at least most of them are from the Rust book. It is surprisingly a very good resource, and for understanding Rust, you don't have to buy any book. It's a free book which is maintained by the community. They have print version, but the online version is the same as the print version. And there is also a Rust by example. There is any question you might have, how can I do this? Then you can just search in that Rust by example book. There's a search function. This book format is also called MD book, which is itself written in Rust. It was created for Rust documentation. Any example, you may have just use a search function, you type there and reading from a file or any kind of how to modules, crates, all the different things are there. I did not cover some things like macros, you can read them on your own. So that's it. I mean, that's all I had. There are no questions, and we'll take some questions, otherwise we can break. Tomorrow I'll just cover some very specific topic called zero knowledge proofs, writing zero knowledge proofs using Rust. Because the initial request for this tutorial was for Trust Lab students who organized the Capture the Flag. I didn't realize that it would be shared with the general student community. But if you're interested and you have some interest in cryptography, you're welcome to attend.